Welcome back from the break, everybody. So we have really had a look at how the nucleus affects the mass of the atom. And yes, that's the number of protons tells us that that is a particular element that we're looking at. We now need to look at what's happening around the nucleus. So what's making up the space of the atom, what's happening around it. And so we come to what Niels Bohr said, and he said that electrons are, they exist in different energy levels, energy states, and they're known as these energy levels. We call them orbitals. They're known as orbitals as well. So if we look at the screen, you can see here, this is what he said. Electrons exist in different energy states. So not all of them have the same amount of energy. And these are known as energy levels. And so he developed a theory that there are different layers of orbitals starting around the nucleus and radiating out around each other. So we have here on the picture, we have the nucleus in the middle. There's the nucleus. And then you can see this first layer here will be the first energy level, and they would be the second energy level. And the electrons with the lower energy state will be in this first level, and we call it N equals 1. Okay, so that the electrons with the lower energy state would be in that energy level. The next energy level would be N equals to 2, and that would be the electrons that have got a higher energy state. Now, when we look at Schrödinger's theory, Schrödinger then went further and he said that these electrons, not only are they in a different energy level, but they also have a particular shape that they, or space in which they move. Now, electrons normally move extremely fast, and this was really difficult theory. You can't really pinpoint the position and the velocity of the electrons simultaneously. It's almost impossible, but he came up with this amazing maths to show us the shape, the space that they take up. Now, we in school level speak about two different kinds of shapes. The first one is the s orbital. So you'll see on this diagram, in the middle, there is a blue-looking sphere, and that is the first energy level. So the first one is S, and it is a sphere-shaped. The second one you see is slightly pink. That one over there is also an S orbital, and it is also a sphere. Now we get the p orbitals. Now the p orbitals are these dumbbell shaped, and they're these orange ones over here. These are the p orbitals. They lie in three different planes. And so the first plane that you would have come across is the x plane. So there's the x plane, and so they would look like this. Okay, the x plane. Then you also know about the y plane. So the y plane is this one that is vertical. That's the y plane. And there's the dumbbell shape or the figure of 8. So you can see here, there's the y on the picture. The x in this one is shown that way. Now, because this is a 3D entity, three-dimensional, there has to be a z axis. And so this is how it looks. I'm going to draw this like this, first of all. So there is the y. Here is the x. Okay. What about the z? So the z plane comes out like that, and you can see it gives then the three-dimensional look about it. So when we're dealing with this one, I'm going to draw a dotted line that way. I'm just going to change my pen so we can see it a little bit more clearly. So this is what the p orbital that lies in the z plane is going to look like. So those are the three shapes. The p orbital is a dumbbell shape or a figure of 8 shape. It lies on 3 planes or 3 axes, the y-axis, the x-axis, and the z-axis. And then the other shape that we have is the sphere. It is the 3-dimensional circle, okay, and that's the s orbital. Now, there are other orbitals that you don't do at school, but I wanted to show you what they looked like because they're so wild and they're so crazy, but here they are here. So the d orbitals, they look like that, and the f orbitals almost looks like a squeaky toy for an animal, for a dog, or for a kid. You don't have to know about those. We won't come back to those again. So we're going to continue. Electron configuration is a way of writing what the electrons are looking like around the nucleus without having to draw those crazy pictures. Some of us are just not great artists, and drawing all that stuff 3D, it is time consuming and it could just end up in a mess. So what we do is we have 2 ways of writing out what the electrons are doing. The first way is an energy level diagram. It's this one here, the energy level diagram, or its other name is an off-bow diagram. It's an old name, the off-bow diagram. And this energy level diagram is using boxes. So here we've got boxes on the screen to show the different levels, energy levels. So we have this picture here of Bohr's model. Over here you can see that this first energy level is n equals 1, and then we go to n equals 2, then n equals 3, then equals 4, n equals 4. So each one of these sections, I'm going to draw a line through here to show you. So that would be the first energy level. Okay, n equals 1. So the first energy level is that first block. Then I'm going to draw a dotted line through here to show you the next energy level. So this is n equals 2. So this is the second energy level. Okay, but you will notice something different about it. It has a single block at the bottom, and then it has got these 3 blocks next to each other. We'll come back to it in a moment. Now, the third energy level will be this one over here. The fourth energy level does exist. I have run out of space. I will show you a little bit later. So what is this first one? Well, this first one is an s orbital. That's the spherical orbital, 1s. Okay. Now we go to the second energy level, which is also starts with an s orbital, a spherical orbital, but it also has p orbitals to it. So this is the 2p orbital over here, and it would be the x orbital, the y orbital, and the z orbital. Okay. The same applies with the third energy level. So it would start with an s orbital, the sphere, okay, and then it would move to the 3p. So you can see that we're going up from a lower energy state, up to a higher energy state. So that would also be the x, the y, and the z. How do we use this now? So I have given an example here. Let's say we are using sulfur. Sulfur is the element, S is its nickname, its symbol S, and 16 is the atomic number, which means that that has 16 protons in its nucleus. If it's neutral, it's going to have 16 electrons. We have this rule, which is Pauli's exclusion principle, and you need to know this one off by heart. It says that there is a maximum of 2 electrons in each orbital, provided they spin or they have the opposite spin. So electrons can coexist, but they have to be spinning in the opposite directions. We, in this format, this off-bow diagram or energy level diagram, we use arrows to show the direction of the spinning of the electrons, and the arrow itself represents an electron. So let's have a look. We've got 16 electrons to place. So we put here 1s. According to Pauli's exclusion principle, we can have a maximum of 2 electrons. So 1, 2. We move to the second energy level with the spherical orbital, the 2s, 3, 4. Now we go to the 2p orbitals, x, y, and z. Now, electrons will like to be on their own. So we're not going to place 2 together straight away. We're going to make sure that we've got at least 1 electron in each orbital. And this is actually Hund's rule. So let's have a look. We're going to say we've got 1, 2, 3, 4, 5, 6, 7. Then we go back to the x orbital, 8, 9, 10. Okay, right. Second energy level filled. We're going to move to the third one. So the 3s. How many have we got so far? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We go to the 3p. 13, 14, 15, 16. There we go. That is the configuration for sulfur. Now we've got another way of writing this electron configuration, and I'm going to do it below. We're going to have S16 equals, what is its configuration? We've got 1s orbital with 2 electrons in it. The 2s orbital with 2 electrons. The 2p orbitals with 6 electrons. The 3s orbital with 2 electrons, and then the 3p with 1, 2, 3, 4 electrons. So that is what we call the electron configuration. Aufbau diagram with the squares, electron configuration, writing it out in a single line. Right, Hund's rule is the last thing we're going to touch on. Hund's rule says no electron pairing takes place in the p, d, or f orbitals until all the orbitals of that specific group have at least 1 electron. And that's what we have just done. So if we look at this picture, we cannot fill this orbital here. I'm just going to change my color so you can see it. We cannot fill this orbital until this s orbital has at least 1 electron in it. The same with the other p orbitals. We can't put 2 into this y p orbital unless we've got a single electron in the x and in the z p orbitals.